Have you ever wondered how the sun, a giant ball of gas, can burn so brightly in the vacuum of space where there is no oxygen to fuel its flames? In this video, we will explore the fascinating science behind the sun's fiery burn without the need for oxygen. Before we get started, if you're new to the channel, be sure to hit that subscribe button and turn on notifications so you can be the first to see our latest videos. To understand how the sun burns without oxygen, we first need to take a closer look at its composition. The sun is primarily made up of hydrogen gas, with helium, oxygen, and other elements making up a smaller fraction of its mass. The key to the sun's bright burn lies in a process called nuclear fusion. In the sun's core, hydrogen atoms are squeezed together by intense pressure and heat until they fuse together to form helium. This process releases a massive amount of energy in the form of light and heat, which we see as the sun's bright glow. But if the sun is primarily made up of hydrogen gas, why doesn't it need oxygen to burn? To answer this question, we need to take a closer look at how combustion works on Earth. On our planet, combustion typically requires three things: fuel, oxygen, and heat. Fuel provides the material to burn, oxygen provides the necessary oxidizer, and heat provides the activation energy needed to start the reaction. When these three elements are present in the right conditions, combustion occurs, releasing energy in the form of heat and light. However, in the vacuum of space, there is no oxygen to serve as an oxidizer. So how does the sun continue to burn so brightly without it? The answer lies in the intense pressure and heat at the sun's core. In the absence of oxygen, hydrogen atoms can still undergo fusion and release energy in the form of light and heat. This is because the extreme conditions at the sun's core provide the necessary pressure and heat to overcome the repulsion between the positively charged atomic nuclei and force them to fuse together. In fact, the pressure and heat at the sun's core are so intense that they create a plasma state, where atoms are stripped of their electrons and become charged particles. This plasma state is essential for nuclear fusion to occur, as it allows the atomic nuclei to get close enough to fuse together and release energy. Now that we understand how the sun burns without oxygen, let's take a closer look at its energy output. The sun produces an enormous amount of energy every second, with about 4 million tons of mass being converted into energy every second through nuclear fusion. This energy is released in the form of light and heat, which radiate out from the sun and provide energy for life on Earth. In fact, the sun's energy output is so powerful that it drives the entire ecosystem on our planet, from photosynthesis in plants to the food chain in animals. But what happens when the sun runs out of hydrogen to burn? As the hydrogen in the sun's core is converted into helium, the core will shrink and heat up, causing the outer layers of the sun to expand and cool. This process is known as the red giant phase, and it will mark the beginning of the end for the sun. Eventually, the sun will exhaust all of its fuel and its core will collapse in on itself, creating a supernova explosion that will release an incredible amount of energy. After this explosion, the sun will become a white dwarf, a dense ball of gas that will slowly cool over time and eventually fade away. In conclusion, the sun's fiery burn without the need for oxygen is a fascinating phenomenon that is powered by the process of nuclear fusion. The intense pressure and heat at the sun's core allow hydrogen atoms to fuse together and release energy in the form of light and heat, which provide energy for life on Earth. However, this process will not last forever, and eventually, the sun will run out of fuel and undergo a massive explosion before cooling and fading away. Understanding the science behind the sun's burn is not only fascinating but also essential for understanding the history and future of our planet. That's it, we've reached the end of the video. If you made it this far, you're one of the best people out there. Before you go, make sure to give us a like to let us know you enjoyed the video. And if you have any questions that pop into your head in the middle of the night, feel free to leave them in the comments below so we can answer them for you.